We have a great pleasure to welcome Mr. Michael Stanley Gallisdorfer today with us, who is a water sustainability strategist and a water expert, a global water expert. And what we're going to talk today about is water, the future of water, and how water technology or water generation technology can eventually help us to answer some questions that we may have in terms of also the implications that climate change is bringing upon us, and the challenges which we see already now with water scarcity or reduced availability of water all around the globe. So it's a great pleasure, Michael, to have you once again here with us.
And thank you for having me very much.
It's a great pleasure, and hopefully it will work out also from the technical side. I would just start with a slide, a very brief introduction why we are having this type of discussion. So Frogeex is a green tech marketplace. We're looking to bring people together, experts, companies together, of course, with people interested in finding the right solution for their problem. Now, when we talk about green tech, it's a very diverse options that you may have or think about this term. We look at solutions in water, waste, sustainable building, and sustainable living. And I already mentioned water. Water is kind of a key element. I mean, we are not talking about buildings or infrastructure only. We're talking about human life, about how civilized or civilizations are basically being organized, and what kind of importance this commodity has. So I think it's just a very slight intro also for the diverse audience that we may have. Water is, I mean, we know that all organisms started in water. We developed from water. The human body consists with 60% of water. And when we look for any advancements, whether it's industrial or it's any type of civilization advancements, whether it's even our efforts to travel to other planets, we look for this type of commodity to be able to survive our life or the survival of our race. So water is extremely important. Now, what we see as well is with climate change, there are a lot of factors, a lot of implications already visible. The signs are already there, whether we talk about progressive desertification, or I mean, I love your posts, and it's always very impressive to follow, what kind of elements you bring in the discussions, what type of perspective. And we see already the signs there. My question now to you would be, before we go into the details, is now also to show or to share with our viewers your background. You studied geography. So how did you come basically from the area of geography, now being an expert in water, looking at the global scale, at the global problems, and connecting it also to climate change, to sustainability? What brought you here?
Well, so yes, I did complete a PhD in physical geography. So one of the things about geography is that geography is an inherently multidisciplinary field. It's not a field where being hyper specialized is always the best way to go. And so one of the nice things about my background is that I got to look at a lot of different things. I came from a program that was focused on the restoration of the Great Lakes, the restoration of urban stream systems, so applied water in so many ways. And there's no way to really solve that kind of problem, a problem of that scope, without being able to understand every part of the system. And that means people, the inherent functions of a place, the inherent unique qualities of where we live and what we do, our cities, our towns, our countryside, and also understanding the background science engineering behind it. Because remember, all decisions are at the end of the day made by people, and water is at the center of all of those decisions, because we forget it oftentimes these days because we've had water abundance in the West and developed nations for a very long time. So before that, I spent a lot of time doing other things. I spent some time on a National Science Foundation undergraduate research program in Virginia, looking at how stream systems worked. And they worked a lot like sewers because we don't think about water, right? We just build and build and build and build more, but don't ever build in such a way that we can work with nature, not against it. And so that was apparent over well, almost 15 years ago right now. And before that, I like to think, my first degree is in philosophy, the approach to wisdom that we all really want to have. And tying this all back into water, there was an early pre-Socratic Greek philosopher named Thales, and his idea was that everything was flow, right? Things are constantly changing. So that's where I'm coming from. Water is at the center of the global economy. Water is really also the measure of climate change, and being able to manage and account for water risk means that you have more stable investments. And I'm not giving advice because I'm not an investment banker here. I'm just saying, if you want to protect your investments, you've got to have water because everything needs water. That's how I approach this.
Mm-hmm. Wonderful, wonderful combination, first of all. And I like the spin how you also connect the dots between different fields, because that's also how complex the issue is. In terms of climate change anyhow. So, and also very interesting perspective that you linked it with risk management and water. So recently I just saw a piece that 90% of climate catastrophes or natural catastrophes are connected to water. So that would basically be also quite an interesting point that would support this. Now, your field, your expertise goes, from every perspective, it all comes back to water. Water sustainability, how do we use it? How what kind of technology can we utilize? How we can improve it, where we can go. So why do we need more of such people, such expertise, and how we can achieve this? To make people also understand eventually, or what is the challenge that you see also in this matter?
Well, the simplest thing is that people get stuck in their ways of thinking. We've been doing water the same way for a while now. You look at how we treat municipal drinking water from that perspective. Get the water from nature, get it from a desalination plant. And if it's gotten from nature, we have to purify that water. We have to treat it with chemicals, other kinds of processes. Well, what if we just skip that? What if we found a way around that? What if we didn't have to wait for the rain anymore? Looking at it from another perspective, we think about stormwater as something to get rid of. And this is a thing that has happened throughout the US and through parts of Europe also, in a lot of places. In fact, any developed place, we try to get rid of that water as fast as possible. Get it out of the city, into pipes, into culverts, out into lake streams, rivers, and the ocean. But that's a wasted resource right there. So turning waste into wealth. Stormwater used to be captured and stored for the dry season in many places. You think about managed aquifer recharge right now in the Western USA. That's just a reimagining of an old idea. This was being done high in the Andes a long time ago. So to really tie it back to the high level concept that we're discussing, water, it's time for water to be disrupted. It's time for us to think differently about water. It's not just something to get rid of or to treat. It's something to really integrate into our lives and to be fully aware of. So how do we get water in our houses? From pipes, or is there an alternative to this? Can we create a more distributed, diversified, and decentralized, a more democratic form of water that makes us a more robust and resilient society? It's changing how we do water supply.
It's I think you're just the right person for this, because you're very innovative in the way that you're thinking about things, the concept. So, and it's a super interesting field that you're just touching in this matter. So when we talk about climate change and the implications on water, especially, now you are very competent in terms of a global perspective, looking also at other regions. So what would be like your signals for climate change in the regions of the world? What would you say now? This is already an indication we are starting to have problems. I mean, let's do seriously something with it.
Well, we are certainly having problems because, you know, what used to be a drought, for example, in the Western USA, which I'm most familiar with, it's no longer a drought. It's a long-term trend of aridification. And that means that everything that we've relied on, everything that we thought was stable in the way of water isn't. We made a lot of assumptions when we were younger intellectually as a species. You know, even 50 years ago, we thought that things were static, that the world would just keep continuing the way that it does, but we now know better. So why is this happening? Okay, like let's just look at it from the perspective of climate change. Yes, climate is changing. There is evidence, we can observe it. Now, why is climate changing? I'm not really going to touch that one. I'll just say briefly, natural factors and human factors probably are combining to make a bigger change. Now, what does that mean for water? Well, let's look at it from a very, very high level perspective. Let's look at it from the top down to start. Let's think about global atmospheric circulation. Let's think about Hadley cells. So at the tropics, we've got warm, moist air rising in the intertropical convergence zone. It reaches a high altitude, and then it falls down, I think, around 30 degrees north and south, which is where we see the formation of deserts. This cool, dry air comes down and desiccates and dries out the land. Well, those zones are expanding. They're growing at around 50 kilometers, 30 miles in the northward and southward direction each year. So this atmospheric circulation pattern is getting bigger, which means that deserts are growing. It's happening. And what that's doing is it's taking a lot of places that were sort of marginal places for agriculture and civilization, and it's turning them into deserts, which means we have to change how we think about how we're going to get water there, because we can't rely on intermittent flows. We can't rely on seasonal rainfall. You know, we can't rely on regular monsoons. Like, for example, in the Southwest USA, there was a reliable monsoon season at one point where we would get moisture, and there just isn't anymore. We can't rely on it the same way. So these changing atmospheric circulation patterns are changing how we get our water delivered. And what that does is it opens up a lot of opportunities for innovation and disruption in the water sector, because, well, what's easier to do? Find a new source of water or move entire cities? I think it's easier to figure out how to get water from sources. And that doesn't mean big pipes. And it doesn't necessarily mean more groundwater, because, you know, if you're piping water, say, from a lake somewhere or a river or whatever, well, where does that river or lake get its water? And is that changing too, right? And also, how much does it cost to maintain that infrastructure? You know, if you're a government, what you really want to do is you want to get the most you can for the least investment. You know, what's going to really work? Because you don't know where your tax base is going to go. You don't know how revenue is going to go. You want things to just work cheaply and reliably. That's what, you know, that's the idea of government. It's the ultimate nonprofit corporation. Just get the most essential things done. And pipelines are expensive to maintain, and they're also very vulnerable.
Okay.
Pipelines are super vulnerable. I mean, think of what happened in Tampa, Florida. I think it was last year. You know, somebody attempted to play with the levels of chlorine in this, you know, growing urban center's water supply. Yeah, the way we're doing it, decentralized ways with big infrastructure, that's not the solution to everything anymore. Now, what's another thing that we can look at when it comes to changing how we approach the water supply in these drying areas? Well, there's atmospheric water generation and brackish groundwater desalination. So the thing about groundwater first is that it's finite. You know, just like those lakes, streams, and rivers, that groundwater is replenished from some source, and it takes a very long time. So if we move from, say, sweetwater groundwater extraction wells, if we move to brackish water desalination from brackish groundwater, we're still depleting a finite groundwater resource, or at least one that has a very, very, very long recharge time, not renewable. Now, there is atmospheric water generation technology. People can go many ways with thinking about this technology, but guess what? So we were just talking about the Hadley cells. Well, they're pumping moisture into the atmosphere, and it gets circulated around the entire world. It's like it's doing the work of boiling the water for us, which it is, because it's using the sun's heat to do it. So we're constantly putting more and more water into the atmosphere. Now, tying this into the idea of climate change, well, so what happens when the world gets warmer? The air can hold more water vapor, and more water vapor traps even more heat. So since the globe has been getting warmer, we actually have much more water in the atmosphere. So why don't we just take it from the atmosphere? Like, why wait for here?
Michael, sorry to interrupt you. I'm just curious. I mean, are there any, I mean, this is, and you are a pioneer, or at least that's what may appear when seeing your content, because you're just coming up with such ideas, and atmospheric water and these atmospheric rivers are definitely one of them. And I love that you share information about this because it's so much needed. But the question is, does it also, I mean, from your perspective, carry some risks, some side effects that maybe should be considered before, or actually we can afford just not to try it out? Or, you know, what is your point of view on that as a water expert?
The biggest risk I can think of is relying on one source for water, which is what we've been doing for a long time. Is there something inherently risky about the technology? I don't think so. I think the two biggest risks are, one, being over-reliant on any one kind, and two, not knowing limits. You know, how much can you really take, right? So if we're able to identify how much we can sustainably take from the atmosphere, I think it's fine. If we also have backup systems in place, I think it's fine too. So say there's a rare case where humidity drops below, say, 10% in a marginal desert area, and we just can't make that much water from air. Well, guess what? We've been saving water in underground managed aquifers for a long time. So we have a water battery. And if that doesn't work, guess what? We also can work with brackish groundwater if we need to. So the key is to have multiple sources, have a diversity of water supply, not be over-reliant on one.
Wonderful. And you already also indicated something similar in one of your points where you mentioned decentralization of water supply. So I mean, how do you envision that, or do you see also some kind of implications for maybe residential use? Having, yeah,
yeah. I mean, look what's going on with, you know, military facilities around the world. Those are the real pioneers in decentralized distributed water, because they all need to be able to execute on their orders and complete their missions. These facilities need to have water, and there are several examples of facilities that do have different kinds of water generation systems in place. Now,
if you could name or share like a best city that has this diversity in terms of water supply, or is taking extremely well care of their water supply in this matter.
I think right now Port San Antonio is a good example. They're in San Antonio, Texas. They've got an atmospheric generation system from Genesis Systems, one of their large commercial water cube models. But that technology can also translate down to the level of the home. You know, for conscientious homeowners, or say people who are building developments or hospitals or stadiums or anything where you need water reliably and regularly, that technology can translate too, right? So that is what that does is it creates the ultimate in resilience in a system. Because say, you know, you and your neighbor both have some sort of water generation system. You can make water from air, you can make water from brackish groundwater, you can get water from the regular suppliers. Well, say that a city has some sort of natural disaster, say there's a hurricane that comes through, say there's an earthquake, it's very unlikely that that natural disaster is going to knock out all of those systems, right? And the good thing about systems that are like atmospheric water generation systems is that they can scale their production. So a homeowner might even be able to scale their production up. And what does that mean? It minimizes disruption. So it's a way of dealing with extreme events like disasters, whether they're human disasters like warfare or economic collapse, whether they're natural disasters like earthquakes, tornadoes, hurricanes, or even floods. People don't think about floods. Floods all the time will knock out water supplies because they knock out the electric supply because they short out the entire system. So when you have water generation systems making water from air, running off of renewables, off the grid in a city or the country or wherever, you don't really have to go down. It minimizes disruption, which makes your country, your city, your corporation much, much, much more resilient to change.
I see. I see. I mean, that's a great point. And now, when we talk about also this has a lot in common with this integrated water management systems. No, so how from what you see right now, I mean, partially, of course, we don't work everywhere. I mean, you mentioned this example of San Antonio, but we don't work everywhere with such a progressive technology. Or you mentioned also the Genesis Genesis. I'm not quite sure now with the pronunciation. Yeah, Genesis.
Yep.
I mean, they do some impressive technology over there. No, so really great stuff. And but this is not the case everywhere. So I mean, in general, there are very diverse also conditions globally. When you talk, for example, about India or maybe Africa, totally different conditions. So is there like a strategy, I mean, in terms of how to start basically preparing a city or a structure, an infrastructure for improving their capacities or just adapting better to upcoming changes? Yeah.
Yes. Well, let's think of it from a global perspective, from a global geopolitical perspective. So why would a developed nation, a group of developed nations, want to give away these sort of innovative water supply technologies, these new systems? Because, okay, climate change. Think about all the people living in areas that don't have a well-developed sort of infrastructure when they're exposed to change. What are those people going to do? They're going to put pressure on every other country around them, and that's going to stress entire continents. That's what it's going to do. It's going to stress continents. When people start moving en masse, that destabilizes countries because people need food and water and a place to live. It's very, very similar to the kinds of things that happened, you know, with climate change in the past. You know, why did people leave Central Asia, you know, in the time of the Romans? Because of climate change, because either the population expanded or contracted, or there were changes in rainfall patterns. The movement of human populations throughout history is what has shaped our political reality today. You know, so climate shapes our politics. Now, what do we do about places that have not developed as rapidly? Because let's just face it, we're all developing. You know, we're all moving towards a goal of higher development, higher human achievement, just at different rates. So you're familiar probably with the idea of open source technology and open source software. Well, what if we did open source water? What if we just figured out how to use private consumers of this technology in such a way that we could give away some of it too, and say, hey, this is better for your business long term? Because guess what? If we help folks who are, say, in sub-Saharan Africa have a stable water supply, because there's a lot of problems with infrastructure there too, they can become your next customers. So it's kind of a win-win. You know, why do you think Tesla gave away a number of its patents? Because guess what? If you're going to be an energy supply company and you give away patents to certain technologies that need energy, then it creates a customer base for you. So giving away water supply technologies, giving away the basic forms that just work. And for people who want the more advanced forms, the more specialized forms, like big corporations, municipalities, things like that, you know what? It's like Tom's shoes. Buy a pair, give a pair away. Because it means that everybody has enough. And when everybody has enough, we can all play the game together. And what is the game that I'm talking about? Global economy. Because guess what? We are one integrated global economy. And if any part of that economy doesn't have water, doesn't have power, doesn't have food, it can destabilize the entire system, limiting growth for us all. So why give away open source water technologies? Why give away open source water solutions? Because it means our global economy can keep growing and growing sustainably.
Interesting point that you make here. And when we talk also about this progressive technologies or open source technologies, technologies that are just in development, are there any other technologies that you are aware besides desalination, atmospheric water generation, that are upcoming or just, you know, being developed right now, that you can share with us, just to, you know, tell us what is there behind the curtain waiting?
There's lots of really cool stuff coming out now. and a lot of it sounds kind of crazy, but it's really exciting. There's one technology that comes to mind. I had a conversation with a gentleman named Rod from, I think it's N Bioorganic Technologies, and he's got what I call probiotics for your sewer system. So, when our guts aren't working, what do? We eat sauerkraut, take probiotics, eat good food. Okay. Now, there's all these fatbergs and biofilms and all sorts of nastiness living inside of sewer systems. If you've read about it, there's been huge fatbergs extracted from parts of New York City's sewer system, parts of London's sewer system, and I bet there's probably many other cases that we're totally unaware of. So these things are monstrous. They're a combination of lipids, fatty materials, just whatever goes into the sewer, wet wipes, things like that, and they block the sewer. So that means that your wastewater transport capacity is reduced, and this is for the wastewater people. So your sewer has clogged arteries, right? It just doesn't work. So this technology, it seeds the sewer system with some sort of lactobacillus culture, and the lactobacillus outcompetes other bacteria and digests these deposits. So you don't have to go in there mechanically. You don't have to mechanically clean out your sewer pipes. The bacteria kind of do it for you. And what that does is it increases the transport capacity of your sewer system. And what it puts out too is less solid waste, because it's digesting that solid waste too, which saves you a ton of money in your wastewater treatment plant. Because, why spend time and energy on mechanical separation of human waste and other kinds of wastes when you can just digest it and treat the liquid? It's just easier. So beyond that, beyond probiotics for your sewer, which is a really great idea, there's also different approaches to how we treat stormwater. These are, big kind of civil and hydraulic engineering type project, but they also include things like, various Dutch solutions. Don't fight the river, work with it. Expect it to flood. It's going to flood anyway. So what do? You do things like integrate floodplains into your infrastructure planning. You don't try to tell the river that's going to fit into this channel and that's how you're going to do it. And that doesn't work anymore, because you might be getting more rain, especially in the north. In the north, we're getting a lot more rain. Where it's been rainier, where it's been rainy anyway, it's going to even rainier. Think about like Scandinavia. That place is going to be swamped like a rainforest. It's going to get warm in the north and the Arctic. You need better infrastructure, and you need infrastructure that adds more value. So how do you get that? How do you get that done? Integrate floodplains, integrate it into cityscapes like flood parks, places like that. And what that does, interestingly enough, is when you create floodplains in urban areas, they can sequester nutrients, all those nutrients that come downstream from farms, things like that. And guess what you can do with that if you really want to? You can farm those places. You can farm floodplains like people have done forever. The idea of having these big open plot fields in semi-arid areas, it's a modern invention. People used to farm the way it was appropriate to where they lived. We can do that once again. So different ways of planning infrastructure, ecologically sensitive infrastructure, floodplain spanning bridges, those kinds of things. Now, there's also, let me think through the list of technologies that I've been exposed to, that I'm aware of. A lot of people are working with sensors these days. So a lot of people are applying, tech to water. Wastewater surveillance has been a big one. Keeping track of what kind of materials, what kind of diseases might be floating around in wastewater. And it gives you a strong sense of what's going on in your community. People did this a lot with COVID. They would go into a sewer system and sample the waste stream, and they would say, we know that somebody in this population has tested positive for COVID, so we know that it's here now. And that gives us much higher resolution mapping than, say, just relying on people to voluntarily test. So for epidemiological purposes, wastewater surveillance works. Now, extending that idea, there's an Israeli company I talked with, I think it's Kando, and what they're doing is they're looking at ways to monitor effluent from, say, industrial producers of waste. And why do you want to do that? Well, because you don't want to get fined. You want to save your company money, because if you have a sensor that can detect whatever you're putting out into the waste stream that's not within regulation beforehand, what that's going to do is it's going to let you cover yourself before somebody else gets a hold of it and fines you. So it allows you to be more compliant. And when you're able to comply more effectively, you're within regulation and you save money. Now, on the other side, cities and towns and municipalities can also deploy these kinds of sensors to detect problems first so they can fine you. So it works both ways. You can protect yourself and you can ensure that regulations are enforced.
Cool.
And what's
cool point.
Well, there's different kinds. There's one kind of technology that I can't describe exactly how it works at the moment, but it's some sort of plasma technology. And what it does is it decomposes waste in a wastewater stream, and it allows for the reclamation of different kinds of elements in that wastewater stream too. You know, because look, you know, water is lighter than metal. Metal's going to sink to the bottom. So those are a few technologies that I'm aware of.
I mean, super points, and many thanks for sharing. You mentioned also a point around regulation. So do you see already a stricter regulation being introduced either in the US or around the globe that you are preparing eventually also your clients to deal with, or what is your perspective on that?
Well, there's lots of emerging contaminants. Why are they emerging contaminants? Like the biggest one that I can think of offhand is PFAS, you know, polyfluorinated alkyl substances. Well, why those? Because they're found in a lot of common materials like food packaging, flame retardant materials, and we've kind of ignored them up until now. So we're going to see some regulation around that. I think that one of the states in the US actually just began to regulate the amount of PFAS in water. Why do we not want that around? Because, you know, it's an inflammatory hazard to our bodies. And when you have inflammation turns into stress and disease. And that's bad for people because, well, you don't want sick people in your country, because happy, healthy people make a better world. People who are sick and stressed are not a good supplier of innovation, which every nation wants. If you're sick, you can't think, right? So we're going to see regulation around that. We already have. I think another big one too is looking at microplastics, or their lesser known, even smaller cousin, nanoplastics. Looking at, pardon me a second, looking at particulates in water is a big deal. You know, we look at things like total dissolved solids, you know, that kind of thing already. But what about these organochemicals and plastics? Now, how dangerous are they really? I don't know offhand. I'm not an expert in that area. But is it worth keeping them out of the water stream? Yes. Because one last, it's all about reducing known risks and potential risks.
Amazing. And I mean, it's also when you mentioned nanoplastics, we hear a lot about contamination basically with plastics in every area which we can imagine in human being, detected in human body. Is it true that also, I mean, is it a particle that is also available in the atmosphere, or is being transferred in other sources or other forms of water, for example, in snow or in rain, that we have these particles already included in, for example, rainwater? Plastic or nanoplastics or so. I mean, is it in the circulation, in the cycle already?
I don't really know. I would assume yes. I don't know, but I assume yes, because think of it like this. Okay, so cars driving around on the road, they create all this dust from their tires. They get rubber dust, things like that. Think of anything that touches the road surface that's plastic, that gets abraded, it gets kicked up into the air. Yeah, it's probably there somehow. Everyday life is not without risk, right? And our world of modern technologies comes with a whole series of known risks. If we want to enjoy the freedoms of, say, having a vehicle, we must also be aware that, you know, cars come with car accidents, for example. And that's what we're seeing right now with things like plastics. They do a lot of good things for us, but they're also the result of our repeated use of them. So let's think of the thing also, you know, fires. Anytime there's a fire, you know, all of that goes into the atmosphere. That soot, that plastic debris gets carried up into the atmosphere. And of course, where does it come out? It comes out in the rain, or it gets deposited in waterways, things like that. So like I said, don't know if it's there. I think it probably is there. How could we tell? Well, do some science, right?
Yeah, some studies to come for sure. And I was just wondering, I mean, what is one maybe point before I go into that question, it's just around water efficiency. So how do you see water efficiency or efficient management of water just fitting into the concept? What part would you see is relevant to this activity? I mean, being just more efficient, managing or using water more efficiently.
Well, one, separate water for people and industry from water for nature. Just separate those two cycles. Like, just separate them, because if we have a closed water cycle, we can then regulate our water better. And it also means that we can allow nature to regenerate, because we're not constantly causing problems by dumping our waste into nature.
Mm-hmm.
Two, water recycling and carbon capture systems are out on the market now. There are some technologies where you can recycle water a few times, maybe twice, 3 times at max,
mm-hmm.
because before you have to add some new water to the system. But remember, if you're recycling water that's black water, water that's wastewater, there's carbon in there too. And if we start to regulate carbon on a global scale, that carbon turns into money, because carbon is energy. It's how we store energy. So to recap the first two, separate human water from natural water, mm-hmm. allowing both to do better. 2, water recycling systems that can recapture water, recapture heat, recapture carbon, recapture materials, all of it. Let's get away from digging stuff out of the ground and throwing it away to getting towards recapturing stuff before it goes into the dump or into our water. It's creating a whole different kind of economy. People talk about the circular economy. Mm-hmm. That's what this is going to do. The third part is, again, we're going back to something I mentioned earlier, which is, this diversification of supply. If you're in a building, have a few ways of getting water. Don't just rely on the grid. Have an atmospheric water generator. If you have access to groundwater, have some sort of groundwater source. Mm-hmm. If you experience severe, prolonged periods of drought, have cisterns and water recycling systems. Mm-hmm. So don't build the same way everywhere. Build where it's appropriate to build that way. If you're in the far north and you're in some Scandinavian community, say you're in Oslo and it's raining all the time, well, figure out how to generate power from all that rainwater. Figure out how to farm wetlands. Mm-hmm. Do something useful with it, right?
Super efficient. I mean, I love that point. So just goes also a little bit to my end or final question to you. So how do you envision the future of water on Earth or where else, or how do you see that? How is it? Is climate change really? I mean, just to be a little bit more provocative in the end. I mean, we had a previous discussion on this. Climate change is not really a good thing, but is it? Does it present only risks, or is it maybe eventually also an opportunity to eventually do something different or better even?
It's a great opportunity. It's. I mean, this is going to sound crazy, maybe because it is, but climate change, and I'm also not afraid to say it. Everyone focuses on these negatives. Well, remember, there are 2 sides to every coin, right? So yes, the Hadley cells are expanding. It's getting drier in some places. That's going to probably cause displacements. But what it also does is it increases the value of water in cities that are in deserts. And it's already pretty valuable, especially in Middle East, North Africa countries. It's valuable in parts of China that are dry in the north. And it's going to make water even more valuable. What does that do? Well, it creates a pull, because let's face it, people want to make money. They want more. And some people, for some people, money means more. For other people, more means, doing social good. But we're all different and we're all in the same world. So what's climate change going to do? It's going to disrupt how we think about water. It's going to change the face of water and change how we deal with it. It's also going to open up a lot of opportunities for people to do really interesting things with natural water systems. So think about the thawing Arctic. Okay, it's thawing. All right, good. What does that do for us? It creates lots of wetlands. And there are crops that grow very well in wetlands. We just haven't really worked with them too much. I mean, rice, for example, works pretty well. But say in North America, which I'm most familiar with, there's wild rice, which grows in Minnesota and the area around there, which is a native food crop that grows in wetlands. You can eat cattails. You can eat cattails from wetlands too. There's all this great stuff that you can eat. So let's think about a warmer, wetter north as a new frontier for agriculture in some ways too. Also, think about places like the Great Lakes. So I'm from the Great Lakes. I'm from a city called Buffalo, New York, in the Great Lakes. And why am I so big on separating the human water system, the water cycle, from the natural one? Because guess what? These northern lakes, which used to be frozen more of the time, they're now open and available for different kinds of things, like agriculture. We used to use the lakes primarily for commercial transport, but before that, there were fisheries. So you separate the human water system from the natural water system. That's an opportunity to restore the lakes, which are now warmer and wetter, which means we can restore fisheries and places like that. So we don't have to transport food from all parts of the world. We can grow food locally at home, making us a much more resilient civilization. We can also do things that combine problems with solutions. So in the southwest of Lake Erie, down by Ohio, in what's called the Maumee Basin. The Maumee is a river. It used to be part of the Great Black Swamp. There's lots of nutrients that are pouring into the lake. Well, why don't we just farm the lake? Floating gardens work. The Aztec used to do this in the Lake of Mexico. What about just doing that on a larger scale? Now, and I'm sure people are kind of just like, what are you talking about? You're crazy. But the thing is, I'm not, because people have done it before. We've done this before. Floating gardens, cultivating our own fisheries. We are not at the mercy of our own wasteful and profligate ways. We can turn climate change into a great opportunity to grow a real lot of food where people can actually live. Like, why farm the desert if you don't need to? We can use this tremendous opportunity to farm the north, where people are going to move to because it's temperate and wet and sustainable.
So it's, also listening to you, a lot of the activities which you mentioned and the actions which we potentially also are gonna take up at some point are connected to adaptation. It's a lot about adaptation. And is there still something you would like to highlight in the end in terms of mitigation related to water, where or climate change mitigation, where we can still prevent some negative effects to come upon us in full scale and in the full impact that we are not yet on the journey basically to explore?
Well, there is no stopping it. It's happening. But think of it like this. So in Aikido, you don't try to stop. If someone tries to strike you, you don't try to stop it. You just work with it. You move with that energy. You learn to fall and roll and get up. So the principle behind that is, we're not screaming and crying and stomping our feet and yelling at politicians to solve the problem for us. We're not sitting there saying blah, blah, blah. That doesn't help anything. What we do is say, okay, there's not going to be water here. We're going to solve this problem in these ways, and we're going to try these new technologies out. The way that governments can support it is by setting aside funding for really risky demonstration projects, just to prove that it works. The way that corporations and private interests can help is by taking chances on things like ESG and saying, this is a way for us to stabilize our investments and to make our business more reliable. We're reducing operational risk. Finally, if you want to talk in like the biggest possible scale, the scale of space and time, if we can figure out how to manage water effectively on Earth and manage change on Earth, what does that mean? It means that when we get to places like Mars or the moon or wherever, we've done a lot of the work already, because we already have invented a managed human water cycle. We know how to deal with it. We have the technologies to work with it. We can use groundwater if we need to. We can make water from the atmosphere, and we can recapture carbon too. We can make fuel, we can make water, and we know how to work around these sort of artificial ecosystems that we're inventing. That means that we can colonize other places in a way that is reliable and functional and sustainable. That's the craziest thing I'll say today.
it's an impressive discussion with you, and fascinating to listen to you and to your ideas, and an absolute pleasure to have you in this episode and sharing with us also your perspectives and the knowledge which you carry with you on this subject. And I hope we can share some of these and transfer that also to the wider audience, so that we just make the topic a little bit more understandable. That's why we started from the basic stuff to basically also going into technical or more technical details, because it's such an important element, and the value of water is not yet recognized by the wider public, not for sure, and it's really a big attitude change in general as well. So
Certainly.
so it's a lot of education as well on the path, I would like to say. And yeah, thank you so much, Michael, for being with us. I do not have any other questions. Is there anything that you would like to still give away from your time and the knowledge and your ideas to how to get ready for what is coming? And but I think you nicely put it together in terms of facing the facts that we're on the journey and just start working with what you have. So being in the flow, respecting the natural cycle, start being in the flow or accepting it.
You cannot fight it. Nature is bigger than you and me and all of us. And it's time to stop complaining and time to start doing.
Exactly.
Doing and stop. It's time to stop worrying and time to start taking chances. And I know it's scary, and people, despite what they say, people are not out of the box thinkers. Typically, they're not risk takers. People, but guess what? Next time that you're afraid to think about water in a new way, just go ahead and do it. What if there is another way, and try it out? Because the only way we're going to get to where we need to go as a species is by trying new things. And all growth comes with risk.
That's true. That was a wonderful conclusion in the end. So Michael, without any further ado, I would just say once again, thank you so much for your time, for being here today with us. I hope we're going to have a follow-up session maybe at some point, just to maybe we're going to have some interesting developments in this area, and share some more on this one as well. So again, thank you so much, and I would wish you a very good rest of the day. To all our listeners and viewers, please follow, like, share whatever you consider relevant. You can come across this content and this discussion certainly on our channels, on our social media channels, and I highly encourage you to also follow Michael Gallisdorfer, because it's a massive opportunity to learn a lot about water, and you're going to be astonished all the time when he's putting out some stuff. So it was a great session today. Thank you so much.
Thank you, Jenna. I really appreciate you having me on today, and I do hope to have a follow-up soon.
Looking forward to that already now. So
have a good night.
You too. All the best.